All right, so from our previous lesson, we learned what probability is. We learned that probability is the chance of getting the desired outcome out of all possible outcomes. And probability is always expressed as a fraction or a decimal. So that's why you can see it as what are the odds of me making this shot. And someone can say 1 out of 3 or 1 out of 10 shots will go in, right? That is a probability, an example of probability. Or sometimes you can then say instead of 1 out of 10, we say 0.1. Okay, so now probability is always a fraction. So meaning maximum probability you can get is 1, which means it's 10 out of 10, right? The probability that the sun is going to set in the west is 1, because that is a probability. But the probability maybe of saying, okay, are you going to give birth to a boy or a girl, that is can be split halfway, right? Because it can either be a girl or a boy. So that is what probability is. So right now I still have the rubber animals in front of me. I have the green, 3 green animals, and I have 2 yellow animals. And I'm going to show you how you can illustrate that on a tree diagram. So we are going to be learning how, with replacement, you can calculate probability or multiple probability with 2 choices. So maybe let's start off with 1 choice. What is the probability that I can pick a yellow animal from here? It's 2 out of 5, because we have our total possibilities are 5, but our desired possibility is 2 out of the 5. So if I was to pick this one, it's 2 out of 5. Now for the green, it's 3 out of 5, because we have 3 of the desired and still 5 at the base. So now when we are now talking about many choices, so I pick, and then I come and pick again, and it's random. I don't have a preference, I don't have a bias. Where you have a preference, we call that a bias. But if we're coming unbiased and just picking at random, that's where the laws, the conventional laws of probability kick in. So now let's, I hope you can see what I've written here. I've drawn a tree diagram. So this is the first choice, right? So someone's going to come and make 2 choices. What's the probability that they pick 2 yellow ones consecutively, or we can say a yellow and a green one? We'll find out today. So this is how you calculate it. All right, what is the probability that I make a green? It's 3 out of 5. What is the probability I pick a yellow one? It's 2 out of 5, because there are 2 here out of the 5, and then it's 3 out of 5. So again, so let's say I was to pick it and I was to replace it after. So I pick it up, I use it. I don't know how I'll be using this, but yeah, I pick it, I use it, and bring it back. But like a good person, a reasonable person, you return things where you found them. And then I have to come back again tomorrow and pick. Now I'm picking at random, and then maybe tomorrow, yesterday I picked a green one. I still have 5 because I replaced everything. So if I'm coming back tomorrow and I'm going to pick another green one, what is the probability I'm picking this one? It's still green, just like this one. The probability is saying, what's the probability that I pick a green one? It's going to be, again, 3 or 5, right? What is the probability that I pick a yellow one? So yellow is again 2 out of 5. I'm replacing. What is the probability that I pick a green one again? Well, I still have 3 green because they've been replaced. So this one is pretty straightforward, as you can see. So now, because we are going with different choices, we're going to have to multiply these probabilities, because they are mutually exclusive. Meaning, this choice, this person choosing a yellow one, has now no effect or no connection to them choosing another yellow one tomorrow. So there's no tie-in there. So if there's no tie-in, you multiply. So that is why, if we're going to say, what is the probability that they pick a green one and a green one tomorrow? That's green Here it's, now what is the probability of picking a green one and a yellow one? It's green and yellow. So what you do is, you're going to say this times that. 3 times 3, that's 9. 5 times 5, that's 25. So the probability of the person picking a green one today and picking a green one tomorrow, that's going to be 9 out of 25, right? Because you multiply, since they are mutually exclusive, they have no connection outside of us connecting them here, okay? And then, if the same happens here, we're going to say 3 times 2, that is going to give us, what, 6 over 25. And then, same here, what is the probability of picking a yellow one, then a green one? Yellow, then green is going to give you 6 over 25. What is the probability of picking a yellow, then a yellow? It's going to give you 4 over 25. I hope this makes sense and I hope this helps.